Okay. Okay, I want to. Yesterday, the point of the assignment was to give you a kind of a table exploration of finding out these values. You're going to have the exact same assignment today, but you just have to verify all these things algebraically. Oh, what? that, that is phenomenal. I'm very happy. And so, um, one way that I actually use, if I because when I see a limit, I don't always know what the answer is. And if I don't have a book to check the answer, and I want to verify that I'm correct, one way that I verify it is I go to a table and I type in 1, 10, 100, 1,000, and I try to see where it's approaching, and maybe it will give me an idea. So that's kind of what I try to work towards. Um, I want to go over some basic limits today so we can understand how they might work algebraically. And the first one is this. The limit as x approaches a of f of x is simply equal to, in most situations, it's equal to simply f of a. If you remember, if you had, say, the limit as x approaches 1 of 2x minus 3, you would simply plug 1 into that function, and you would get 2 times 1 minus 3 is negative 1, and that would be your answer. Okay? Um, so that's how we used to be able to identify limits. Now, sometimes you couldn't plug in that number because you would end up with an undefined denominator, and that was a problem for us. Well, now we got a new problem. We're trying to plug in infinity, and infinity is a very big expression. It's not a number, but it's a concept. It's an expression to represent large numbers, and how do we do it? Well, here's one idea. Um, the limit as x approaches infinity of x to some positive integer power, so let's say it would be x to the third, x to the fourth, x to the fifth, the answer is going to be infinity, given n is positive integer. And what do you think happens if it goes to negative infinity? If n is even, then it's positive infinity. But if n is odd, negative infinity, right? I mean, like, if you had the limit as x goes to negative infinity of x squared, well, if you square it, it's going to be positive. Whereas if I had the limit as x approaches negative infinity of x to the third, well, if you got three negatives, then it's going to be negative, right? So, pretty straightforward, right? Any questions? Okay, let's flip it around. Limit as x approaches infinity of 1 over r, okay, to some power, say squared, third, fourth. Anybody know what that is? If you think about it, it's like 1 over some large number, some very large number to a power. So 1 over n to the eighth or something like that. I mean, if you take a very large number and take it to the eighth power, that's going to be a really big number. 1 divided by a really big number is going to be about 0. And it works the same way here, okay? Works the same way there. Now, let's look at a couple that are a little bit more interesting. Those aren't really all that interesting. If I look at, say, y equals the sine of x, and what I want you guys to understand is that as you go towards positive and negative infinity, that's really along the horizontal axis here. And if I look at this graph and I make this window, I'm going to change my window to -2 and to +2 so I get a better view of this thing. Um, think about this. As I approach positive infinity, is this graph ever going to approach a single number? it's always going to oscillate back and forth, right? Between -1 and +1, so it does not exist. Oh, you got that yesterday. Oh, well, good for you. See, isn't it fun plugging in numbers and seeing how things work? So that's a classic example. Now, I promise you that you didn't get the last two, okay? Um, the last two are significantly more difficult, and you're really going to have to follow to get this last one, okay? Do you remember this one? The limit as x approaches 0 of sine of x over x. We talked about that. Now, it doesn't approach infinity. It approaches 0. Do you remember what that comes out to be? 1. Now, we're going to use that. We're going to use that to evaluate the next one. And you don't have to be able to reduplicate this, but you need to remember what it is, okay? I don't know how to work with sine of 1 over x as x goes to infinity, so I'm going to change something really quick here, okay? I'm going to change this. Write this down. 1 over x is equal to t. 1 over x is equal to t. I'm going to substitute a new variable in. And I get this from your book. Your book set this up this way. I don't figure this stuff out on my own. This is a little tricky, okay? And what we could do is we say as t approaches positive 0, or 0 from the positive side, okay? Think about it, you guys, okay? What number would x have to approach in order for t to approach 0? What would have to happen to x for this expression to be close to equal to 0? X would have to approach infinity. So as t approaches 0 from the positive, x approaches infinity. Now we can make our substitution. We will have the limit. Instead of x approaching infinity, what do we have instead? T approaches 0 from the positive. And instead of sine of 1 over x, we have the sine of t. We made our substitution. What does that graph of sine of t look like? Sine of t looks like this. Right? We're approaching 0 from the positive. What does the output approach? It approaches 0. So this thing is actually equal to 0, and that's why. Okay? So that's what we have. Well, that's the general idea. Take out your homework, and I can show you how to start verifying these algebraically. Because a calculator is an educated guess. Let's do better than an educated guess. So we're going to look at one example, okay? And this will be the most basic example. I'll show you how to verify this algebraically. And it says 1 over 2x plus 3. And I just want to show you what's actually happening here. If we take 1 divided by 2x plus 3, and we were to graph that, um, as x approaches infinity, okay? So as x approaches infinity, what is the graph approaching? What's the output approaching? 0. You can see that 0 represents the horizontal asymptote, or asymptote as I like to say. And so we have a horizontal asymptote here of 0. That's really what it is. Limits as they approach positive and negative infinity also represent horizontal asymptotes. And so graphically, that's what we're looking for. You can see that it's 0. Here's how we verify it algebraically. And generally speaking, not all of the time, but you can save yourself a lot of trouble if you just remember this. If you remember this one rule, divide by the largest power. What is the largest power that we have here? X to the first power. So I'm going to divide everything in the top and everything in the bottom by x to the first power. Now, I can multiply the top and bottom by the same number and not change it. So I can divide the top and bottom by the same number and not change it. So this expression looks a little bit different now. This is going to become the limit as x approaches infinity of, what's the top going to be if I divide it by x? 1 over x divided by 2 plus 3 over x. Now, let's allow x to go to infinity. If x goes to infinity, what will we have on top? 0. If x goes to infinity, does anything happen to this too? Nope. And what happens here? Well, I plugged in infinity. 1 over infinity is going to be 0. 1 over an extremely large number is going to be 0. And so therefore, I have this 0 divided by 2 plus 0, or 0 divided by 2, which is 0. So there we verified algebraically that the limit is in fact 0. Okay? Let's try the next one. Let's try number 10. Limit as x goes to infinity of 3x plus 5 over x minus 4. What is my largest term? X to the first power. So I divide everything in the top. I get the limit as x goes to infinity of, what's in the top? 3 plus 5 over x over 1 minus 4 over x. Now, as you allow x, boys, as you allow x to go to infinity, what does the 5 over x become? What does the 4 over x become? So you end up with 3 plus 0 over 1 minus 0, which is positive 3. So you can see that we verified algebraically that these, in fact, work out like that. Any questions? Yeah, so if you would have, say, x squared over x to the third, you would divide by x to the third on the top and the bottom. I'm going to give you guys about 5 minutes right now to work through a few of those problems, and then we're going to try some more difficult ones. So I'm going to pause this. Yep. Okay, boys and girls, there are trickier ones. You guys are catching on pretty well. But please turn your attention to what I have on the board right now. If I have something that looks like this, the limit as x approaches positive infinity of 7x to the fourth minus 3x squared plus 1 divided by 9x minus 2x to the third plus 3x to the fourth. Now, Taylor Blake raises a really good question, okay? And And I could tell you guys right now by looking at this, I know the answer. Does anybody know the answer to this problem just by looking at it right now? 7 over 3. Really what you can do is you're maybe noticing that all that's really left over is the largest one in the top and the largest one in the bottom, and they divide to give you 7/3. Now, I walked into college, and that's what I said, and the professor was not impressed at all. He said, well, yeah. He said, yeah, I know you guys can know that, but do you know why? And he said, verify for me that that is true algebraically. And I couldn't. I said, I don't know. I know it works, though, and I know the answer. He said, well, math isn't about knowing the answer. Math is about verification. If we can't verify it, then we haven't done it correctly. And how do we know that you've done it correctly unless you can verify it? So that's something we need to be able to do. So you can see right away sometimes what the answer is going to be, but we still need to be able to show it. I would like to do problem number 17, which is a slightly more difficult for you guys right now. And we'll try that, okay? Yes. Square root of 9x to the 6th minus x over x to the third plus 1. Okay? Now, this is a little bit trickier, you guys. Okay? It's definitely a little bit trickier. And here's why. What is my largest term? X to the 6th, kind of. But if you took the square root of x to the 6th, you would get x to the third. So I'm really going to divide the top and the bottom by x to the third. Now, that's a little bit more difficult on top to do because I have that square root. So watch my algebra here, and please don't lose focus. We are going to, instead of writing divided by, just for the sake of notation, I'm going to write 1 over x to the third times the bottom and 1 over x to the third times the top. Okay? I'm going to write it like that, and hopefully that will help us move through. You will see exactly why right here. As I look on the bottom, what's 1 over x to the third times x to the third? 1. And 1 over x to the third times 1. So that looks just fine and dandy right there on the bottom. But the top is a little bit more difficult. In order to get this 1 over x to the third on the inside of the square root sign, what do I have to do to it? Not square root it, but square it. Remember, if you want to take something out of a square root, you have to square root it. So if you want to put it back in, you have to square it. So this is really going to be the square root of 1 over x to the, what is 1 over x to the third squared? 1 over x to the 6th times 9x to the 6th minus x. So now I have it on the inside of that square root sign. Now I can actually do something with it. So I have the limit as x approaches infinity of, what do you get here? 9 minus 1 over x to the 5th over 1 minus 1 over x to the 3rd. Now, as you allow x to go to 0, or to go to infinity, what happens to this 1 over x to the 5th? Oh, I'm sorry, it's a plus on the bottom. I'm sorry. X over x to the 6th will be x to the 5th. So this piece right here goes to 0. This piece right here goes to 0. And you're left with the square root of 9 over 1, which is equal to 3. So that's kind of a trick, huh? Shh. Let me do number 21 for you. Again, this will give you an opportunity to practice some other ones. #21 says the limit as x approaches infinity is square root of 9x squared plus x minus 3x. I tried this 2 ways. The first way I tried it, I came up with the wrong answer. I did everything I thought was pretty fair, but unfortunately it didn't work out. Let me just show you how counterintuitive it could possibly be. I look for the largest term right here. What's the square root of 9x squared? 3x. And what do you get if you take 3x minus 3x? 0. So I kind of thought right away off the top of my head, I was like, well, the answer is going to be 0. And then I tried to verify it algebraically, and I realized the answer is 1/6, right? 0.16 repeating. And so it's like, well, how can that happen? And so as you look at this, you might want to say 0, but it doesn't work out like that. We got to free something up here. We got to free up this square root piece. We need to end up getting those to cancel and seeing what we have in the denominator. So I'm going to multiply by a special thing here. You know what it is? Starts with a C, rhymes with conjugate. Very good. So square root of 9x squared plus x plus 3x this looks really bad, but it's really not too bad at all. What are you going to end up with on the top? That wasn't very nice. 9x squared plus x, right? Minus 9x squared. Because when we do that, they are conjugates, so the middles will cancel. The square root will be gone, and we'll have 3x times 3x is 9x squared, and there we have it. On the bottom, we get our square root of 9x squared plus x plus 3x right there. And as you can see, what cancels on the top? 9x squared. What is my largest term? X. So what I'm going to do is I'm going to multiply the top and the bottom by 1 over x. This piece? I can't. Do what? Yeah, I can't. I can't. Okay, so boys, it's too much. It's too much. Okay, I I hear constant, and I don't want to hear anymore. Okay, I want to talk. So I have x times 1 over x. X times 1 over x will be 1. And now when I multiply the bottom by 1 over x, when I multiply the square root piece, I will have to multiply it by 1 over x squared. What's 9x squared over 1x squared? So my largest term is x, because if you were to take the square root of this x squared, you get x. So I will do 1 over x times x over 1 over x times the square root of 9x squared plus x plus 3x. So now I got to work that through. I get the limit as x approaches infinity of, what's 1 over x times x? 1. Now, when I multiply the 1 over x through this square root, I really have to multiply by 1 over x squared. And I get the square root of 9x squared times 1 over x squared becomes 9, plus x times 1 over x squared becomes 1 over x, 1 over x times 3x gives me 3. If I want to multiply inside a, so let's just say, for example, I had 2 square roots of x. If you want to get that 2 on the inside, I have to square it, right? So that's what I did. Now I can let the limit go to 0, or let the limit go to infinity. What does this 1 over x become? That becomes 0. I'm left with 1 over the square root of 9 plus 3, 1 over 6. Um, so you have a lot of examples now to kind of help you out. There is one more that you probably wouldn't be able to figure out, and that's your last one, number 34. But the rest of them you should be pretty adequate at. So I'm going to let you work here the rest of the hour. Um, there's some good examples for you. So what's that? Yes. Yep. Please verify them algebraically. Yep. Get some good practice. Yes.